Hi, welcome to Curious Minds Classroom. This is the first lecture for Foundation Math. Because it's the first lecture, we're not actually going to talk at all about math. We'll talk about how the class works. And because of that, I really would like to make sure that parents, guardians, or adult mentors who are part of the education of some of our students participate as well, so they can understand who we are, what we're doing, and how we're going to press forward. And really important is what our contribution is to your individual education programs. So in this lesson, we're going to start off by talking about who our target audience is, what we expect our students, who we expect our students to be. Tell you a little bit about myself and some of my background. We'll tell you a little bit about Curious Minds Classroom as an organization. I'll address my learning philosophy, the things that I believe are important in terms of how you learn and what you learn. We'll go through some class mechanics about things like where we're going to post homework and such. We'll cover prerequisites, the stuff that I expect you to know coming into the class, and then we'll talk specifically about what the class is going to cover. We'll wrap up by introducing something I call the Bug Hunter Challenge, and finish it off with our first assignment. So who is this class targeted for? Well, the short answer is anybody 13 years old and up who has holes in their understanding or would like to just have a better, tighter grip on some of the more abstract concepts that go with math. If you're 13 years old at this point, you almost certainly have experienced a lot of arithmetic and a lot of the things that we're probably going to cover in this class. So why would you want to have to do it again? And the short version is that math in its pure form really requires abstract thought. And it turns out that there's a physiological development that doesn't happen until you're 13, 14, or 15 years old that's required before you're really ready to tackle abstract concepts. Unfortunately, the way math is usually taught, you learn how to do it. You learn the process or recipe. You just check in boxes, tick, 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 as you go down. But you don't really get a good handle on why you're doing it that way. And as a result, a lot of times people who aren't very good at just following directions without understanding why. People who have an independent streak in them tend to not do very well at math, especially early on. Another thing that happens is that as you start to develop cognitively into this abstract thought, girls tend to do it about a year later than boys, and a lot of the school schedules are built around the development timelines for boys. So we like to start over and really start from the beginning to build a foundation for why math works the way it does, starting when you're old enough to really start to understand those abstract concepts. So 13 to 15 starting, and to be honest, this is probably a course that anybody up to age 99 plus could benefit from. There's going to be some overlap with stuff you've already done in the past, but I guarantee you that if you think about it and watch, you'll learn some new things that you've never thought about before. Another thing to think about is you may be 13, 14, or 15, and if you get into this class and you realize that you're just not understanding the concepts and you're back to just following a recipe, you might not be ready, and that's nothing to do with your fault. That's just because you may not be physiologically, biologically ready yet. So if you're not ready, take a break, come back and try again next year. All right, so about me. I am a PhD. I finished a PhD in electrical engineering from the Air Force Institute of Technology. Focused specifically in things like laser physics, quantum mechanics. It was a hybrid degree between electrical engineering and physics. My master's degree is electro-optics, which is again kind of that hybrid between those two departments, and my bachelor's was just straight electrical engineering. I spent my entire life in science and technology, so I'm way overeducated, and hopefully I can use some of that to help you guys. Some other things to know about me: I'm a military veteran. I spent 20 years on active duty with the Air Force. They're the ones that paid for all those fancy degrees. In that time, I was a staff engineer. Basically, I advised the higher-ups on how to spend their money and how to rewrite doctrine to leverage new technologies. I worked on nuclear weapon systems. I worked on laser weapon systems. I did electronic warfare, remote sensing, so think about ways to figure out what somebody else is doing from a distance. Flight simulators, intelligence community support, a few other things. Basically, I have the attention span of a squirrel, and I love to delve into new projects and new topics and move along. After I retired, I initially went to go work for Space Dynamics Laboratory, building small research and development satellites. up until October of 2021 when I left to come and start Curious Minds Classroom. I'm a lifelong learner. I can't imagine not having something new to learn pretty much every day. I'm a tinkerer. I love to build projects. I work on cars, I work on motorcycles, I build things, you name it. I love working with my hands. And in fact, when you see videos with close up with my hands, especially on the workbench, if you do like the electronics class with me, you'll see that they're often chewed up. It's because I'm outside in the garage when I'm not doing this, or I'm in the backyard, or I'm in the shop, you name it. Last thing to know is that I'm a volunteer firefighter and EMS first responder. It's relevant to you guys because if we're in a live event where I'm on Zoom with you or we're on the forums and I get a call, I'll drop everything to go and save somebody's life or put out a fire. Alright, so who are we as Curious Minds Classroom? It's, like I said, I founded it when I left Space Dynamics Lab with my wife Elizabeth. Partly because in over 12 years of homeschooling our own family, we've never found anything that quite met our needs, and we thought that we could help bring some of what we've learned over the years to help other people. We build the online courses like this one here to help parents and students in their own education. We are not a complete school. We're not a complete solution. The courses we offer are high quality. We believe that if you succeed in these courses, you'll be well prepared for college. But that's not really what we do. We're not a college prep class. If you want that, you need to go take the ACT or SAT preparation classes. We build courses to teach concepts, not to do well on a test. Because we believe in teaching high quality content, we don't want to be messed with by things like accreditation boards who put mandates on what you can and can't teach and how you teach things. We don't believe in traditional classrooms. Putting 30 to 40 people in a room on a little tiny desk and expecting them to pay attention and really learn is probably a bridge too far. So we really believe in tying concepts to things that are relevant. So one of the things we'll be doing is tying some of the concepts we teach in, for example, the math class, to applications in a science class or technology class. In our liberal arts classes, Western civilization and history will be tied with literature so that they merge together and you can really reinforce that learning. We do expect that families will be supplementing on their own. And in fact, in times we're going to be giving our students assignments to go back and talk with families about what we're touching on in our class and having a family discussion to make sure that the context is set based on your family's values, on your educational philosophy and so on. Alright, so learning philosophy. What do I expect from you as a student? Number one, I need you to understand that I can't actually teach you anything. I can provide instruction, I can describe things, I can put together pieces, I can lay it all out in front of you, but if you don't put in the work, you're not going to learn anything. You have to teach yourself. And part of what I really want out of this is to, at the end of the day, to teach you to learn yourself. Give you the tools so that you have what you need, and then press forward. I try to be as interesting as possible. I hate boring classes. This is probably as boring as we're going to be, I hope. But understand, I'm not an actor, I'm not a comedian, and so sometimes I'm probably going to bore the snot out of you. That's unfortunate, but that is what it is. So as bored as you may be, it really comes down to you to figure out how to be interested in what you're doing. As you look deep into any topic, you'll find things that are interesting about it. That's why you can have somebody who has a PhD in sea snails, because they've looked close enough that they've understood and learned enough about it, they can really be excited about it. For me, I couldn't do that. It would bore the daylights out of me. But I know people who've done that. Some things that will make a big difference in your success, and this is what I really expect out of you. Number one is hard work. Learning isn't easy. It gets easier the more you practice it, but it takes work, even when it's well practiced. The harder you work at it, the more it's going to stick, and the more you're going to be able to use it in the future. The second thing, I expect you to take advantage of the resources and opportunities that are available to you. What does that mean? So, I don't believe that there is such a thing as cheating other than cheating yourself. If you have a friend that you can ask, if you have parents that you can talk to, anybody that you have, or any person or tool or book or or the internet that you can use to help you actually understand a topic, you need to be using that, because that's the way it's going to happen once you leave school. Other resources and opportunities, I'll be hosting office hours where I'm available. You can schedule a time to talk with me directly, one-on-one, and ask questions and clarifications and just generically interface with me. You'd be surprised how often college students who have the opportunity for office hours refuse to use them. I didn't learn until my senior year of my bachelor's degree how good it was to walk into a professor's office and sit down for 20 or 30 minutes and have them explain to me whatever it was I was missing. Number one, the professor loves it because they're there to teach you. Whether the system wants them to do that or not, the system may want to be writing grants and proposals and bringing in money, but the professors love to work with students who are interested. Use the resources. Please use the online forums to contact other class members and get their input and advice. Reach out to me, reach out to your friends and neighbors. How much you learn depends on whether you find the information interesting or valuable. So much of early science and technology classes are lost because they just don't really tie back to something people that actually want to do or are interested in. I'm going to try and give you opportunities to link these to stuff that's interesting. Sometimes it's interesting in kind of a puzzle sense where you're just trying to put pieces together. That's usually the kind of interesting you get when you're in elementary school. And it can carry forward. But more interesting for me and for most of the people I've worked with in the past is whether you can see how you might use it for something else. We'll work hard to tie all of what we do to an application. There's going to be times though where you need to be able to just kind of write it out, take my word for it that it does come in handy and that we have applications for it. As we get past the introductory stuff in the next year and we roll into some of the more advanced math and science, they'll start to link together pretty cleanly, and I hope that if you get that far with me, you'll find it interesting and valuable. The last thing, how much you learn really depends on whether you're ready for it or not. Like I said before, if you get into this class and it's just not clicking, work with me, use some of those resources and opportunities to see if maybe I'm just not teaching it right to you, if I need to reframe it in some way. And then at the end of the day, you might not be ready. Maybe it's time to step back and wait a little bit, come at it again next year. I don't care if you understand how to do something. At the end of the day, what I really want to know is that you understand why it works. If you understand why something works, you understand the ideas behind it, you can usually get back and figure out pretty quickly how to do it. I don't believe a lot in memorization for just memorization's sake. I would rather you know the pieces that feed into it and then be able to figure out using a pretty logical process the step-by-step stuff that most people like to just memorize. Focus on the why. Understand the why, and then do enough of the process to know how, and then that's where we're going to stop. There's not a lot of busy work. We're not going to do a lot of repetition. You can do more if you need to understand it, but ultimately it's about understanding the why. Next one, I touched on this a little bit already, but use the tools you have available. I believe in calculators. When I was younger, they wouldn't let you calculators on a test anywhere, whether it was elementary school, high school, college. They expect you to do everything by hand. I don't see a single reason on this planet why that's irrelevant. Calculators and computers are great at doing the things that are boring and step by step. They follow instructions, they follow a process, they don't think for you. They make the boring parts quicker and cleaner and more reliable. So use your calculator, use your computers, use notes and crib sheets, anything you need to help you understand. Use the internet, but I'm going to put a caution on that because the internet's full of stuff that's just flat out wrong. So you need, and if you're going to use these tools, you need to understand them though. Using a tool without knowing what it's doing, so basically using a calculator without knowing how to do addition, is a bad plan. It's a recipe for getting it wrong, using the tool wrong, and you won't recognize when the answer comes out wrong. If you don't understand what a tool is and how it works, it might be the wrong tool and just give you the wrong answers even when you're using it correctly. Always remember that a good calculator, a computer, your friend, your neighbor, any other tool or resource is no replacement for using your brain and thinking through a problem. You use those to help clear some understanding, especially friends and neighbors. And you use them to clean up to run the process faster, like calculators, but they do not replace yourself. So understand what it's doing, understand what it's for, and then go ahead and use it. So let's talk about cheating a little bit. A lot of the world has said that a lot of what I just told you would be cheating. Using a crib sheet, talking to friends and neighbors, even using a calculator can be considered cheating. You need to know your environment and what it's for. In my classes, I expect you to use all of the resources you can. If you go take the ACT and SAT, they have different rules. They may have rules on what kind of calculator you can have. They're definitely going to have rules on things like crib sheets. You need to check those requirements before you go in, and if they require that you memorize that stuff, take some time and memorize it, but if you understand the how, that memorization will be a lot easier. Another thing to note, use your resources, but you can't just copy it. If you copy it exactly, it's copyright infringement for one, it's a legal problem. You need to put it in your own words, and you need to understand it when you're done. I have no problem working together on homework, as long as it's not just one person doing all the work and everybody else copying it down. If you're teaching each other and you're learning and understanding together, and you come out at the end of it knowing what that content is, knowing how you did it, knowing how you got to the result, that's perfect with me. The only thing you cheat when you cheat is yourself. If you're just writing down an answer to check a box and move on, you cheat yourself, because you're going to miss out on the opportunity later when you need it. If you skip the concept because you just didn't learn it, you didn't want to learn it, and you moved along, we're going to use that stuff again. Math and science build on itself over time. And one piece connects to another, and eventually you end up using just about everything. And if you miss pieces along the way, it's a lot more work to go back and fill in the holes than picking it up as you do it in the first place. All right, so a couple caveats, just to set expectations. Number one, I don't have a dedicated soundstage or production crew. So you're going to hear background noises from time to time. You're going to see that the lighting's not perfect, the audio is not perfect. You might even hear the dishwasher running or the toilet flush, because that happens from time to time. For the most part, I try to edit that out. We try to set things up quiet when we record, but it happens. The other thing is, you're probably going to run into Murphy and Rufus. From time to time, they'll stick their head into frame, and sometimes I might not edit them out. They're my constant shadows. The quietest way to keep them is when they're sitting here right next to me. So just be aware and be a little patient with me. I'm not a professional actor or orator. I'm going to have quirks that are going to irritate you. I'm going to use phrases that just don't sound right. I'm probably going to have verbal pauses. Good example. And I'm going to make a lot of mistakes. Now, if you find my mistakes and you tell me about my mistakes and you help me fix my mistakes, you'll get some bragging rights out of that. We'll talk about that here in just a minute. I already talked about how I might get a call out. I might disappear. So in the video lectures, what you're more likely to see there is I'll come in and dressed like this. There'll be a freeze frame, and I come back and I might be dressed completely different. It might have been 3 or 4 days later when I went back to re-record it. That's often because I got called out and interrupted in the process of putting it together. So if the videos are a tiny bit choppy, that might be part of the problem. Another thing, there's going to be places, especially in math, where I'm writing on a tablet that shows up on the screen. My handwriting is pretty typical for an engineer with 9.5 years of college. It's bad. I do my best to make it legible. I apologize in advance if you can't read it. If you do have a problem with it, though, drop me a note, and I'll work to redo it and repost it so that you have what you need to succeed. Okay, so a lot of the class is going to revolve around the forum. There's going to be a section specifically for this class. Check that forum at least weekly. This is where I expect you to post your questions. If you're not comfortable with the topic, if you need help understanding something, I want you to post it to the forum first. Why? Well, a couple of reasons. One, your classmates have probably already thought about that, and some of them have already answered it. And the best way to learn something and really make sure you understand it is to teach somebody else. When you teach each other, you reinforce both the teacher and the student. When you're on the forums, take some time to look around and see if you can help answer other people's questions. You know a lot. You've already figured stuff out. It does a couple of things. One, it can help you reinforce that you're not the only one who just doesn't get it sometimes. And two, it provides opportunities to interact with other people in a way that's going to be reinforcing for both. I do ask that social interactions that aren't related to the class be handled outside of the class forum. We do have a forum that's just as part of the Commons that's open. Any topic is okay as long as it meets our forum standards. So nothing morally questionable, nothing you wouldn't talk to grandma about in church. Feel free to interact over there and swap stories or whatever, as long as it meets the standards. I do monitor the forums, and if I find something that doesn't meet the standards, I'm going to delete it, and I'll notify the parents of whoever posted it and the person that posted it of the unacceptable content. Ultimately, at the end of the day, though, I'm not going to guarantee there's nothing bad on the forum. So parents and students need to work together to control and limit or appropriately monitor their forum participation. If you do see something on the forum that you find objectionable, you need to let us know, and we'll either take it down or talk to you about it and understand why it does or doesn't meet our forum standards. All right, class mechanics. First and foremost, I don't issue grades. I don't believe in A, B, C, D, E, and F. That's a totally wasted time. If you understand the material, you've succeeded. If you understand the material, give yourself an A. Parents are absolutely within their rights to issue grades according to their perception of how your student works and how they've succeeded in the class. If you ask me, I can provide some input on how I believe they've done. But like I said, if at the end of the day they understood the concept, it doesn't matter to me how long they took, how many tries they took. I think that's an A if you walk away knowing it. Overall, there's typically going to be 3 lectures a week. I expect them Monday, Wednesday, and Friday. But when you take those, you view the video lectures, it's up to you. It doesn't matter to me. The length will vary depending on the content. Could be 15 minutes, could be 45 minutes. This is probably one of the longer ones we're going to have for this class. You can work through the lectures faster if you want to. However, if this is the first year this course has been up online, I'm only going to be uploading them 3 videos a week, so you're not going to get too far ahead of me. Practice problems, homework problems. Practice problems that help you. Do as many as you need to understand the concept. If you understand it solidly and you're comfortable about it, and you and your parent agree, stop. You don't need to do all of them. If you need more practice problems than I've posted, talk to me about it. I can probably generate some pretty quickly and post them for you. At the end of the day, students, if your parents ask you to do them, doesn't matter what I think. Do what your parents say, do as many as they want you to do. Alright, textbook. For the first half of the class at least, the textbook's going to be a draft of a textbook that I have developed for this class specifically. As part of the class, you can print 1 copy of it. This is a pre-print draft copy. Take it to UPS, FedEx, Staples, Office Max, whatever. They can print and bind a copy for you, or just use it digitally. It's all fine. It's a PDF. If you're in the initial cadre and it's still the draft textbook, you will get a free copy of the final version when it comes up, provided you give me feedback on it and help me correct any issues you find in it. Practice problems that I post, reprint as many of those as you want. No limitations, though I'm going to make those publicly accessible. When I do release new editions of the book or new drafts, you'll get those updates for free. So another note about the textbook. It has projects that are labeled as try this. They're not homework, they're not assignments. They're there to help enrich your learning and kind of stretch your understanding a little bit. I recommend them, but whether you need to do them or not is kind of between you and your parents. If you get stuck on one, don't give up. Some of them are challenging on purpose. They're intended to take the concepts and push them just a little bit farther within your own mind. If you get hung up, reach out. Like we talked about before, use the forum, reach out to me, talk to a parent or a friend. Use your resources. Always use your resources. I talked about it already. I will be having office hours. This is your chance to talk to me directly. Sometimes those will be via Zoom, and there'll be small groups where anybody can jump in on it. Sometimes there'll be things that you can schedule ahead as a block of time where it's dedicated one-on-one. I'll be posting the office hours on the forum and on the website on the events calendar when they're available. It's available on a first-come, first-served basis. If we start continually running out of office hours, I may have to prioritize some people or potentially open up some additional hours depending on availability. So if you can't come in during office hours, you can reach out to me and we can possibly open up outside hours that'll be a little more flexible for you, but we'll play that on a case-by-case basis. All right, so what are we going to talk about in foundation math? Basically, it's everything from what is a number all the way up to pre-algebra and geometry. Everything you need so that next year you're ready to jump into full-blown algebra. I don't believe in Algebra 1 and Algebra 2 because they're basically rehashes of the same thing. You're capable of covering both those materials in a year. Pre-algebra, 6 months. In one semester we can cover everything you need to know. We'll cover geometry in 6 months. If it sounds fast, that's because we're not going to waste a lot of time with repetition. This cloud course is suitable for a first introduction to people who have never taken a traditional approach to doing math. It's also a suitable course for people who have just had holes because of the way they learned it or because they just missed pieces along the way. If you ride with us, you'll find something new, even if you are very good at math. So the first semester is going to be focused on pre-algebra, and we're going to start with basic concepts like quantity and numbers and a number base. What those are, we'll talk about as we go along, but really it's about how numbers work in general. And the two alternate number bases we'll talk about are binary and hexadecimal. So there are a lot of different ways you can organize numbers. The way we normally do it is based on 10 because we have 10 fingers and toes. Binary does it groups of 2 and hexadecimal does 16, and that's based on computer architectures. Now, there are other ways. We'll talk a little bit about one of them, but for the most part that's it. We'll go through math grammar. And what do I mean by math grammar? Well, math is the language of science. And so just like in grammar, we have nouns and verbs and adverbs and adjectives. Math has something equivalent. We have operators, operands, order of operations. We put things in specific orders. We relate them together. We'll teach you how that works and some of the main features of it. We'll go through basic arithmetic. Sounds really boring, right? But we're going to talk about how you add, subtract, multiply, and divide, but we're going to do it in that context of understanding how numbers work, and we'll start to understand why when you do hand multiplication, addition by hand, long division, they actually work. Now, once you understand why they work, I don't expect you to ever do it again. I expect you to use a calculator. But I do want you to know how it works, because at the end of the day, things like computers have to be programmed to do it the hard way. And I expect that in next year's technology class, we're actually going to build parts of a processor manually, for example, to do long division with binary numbers. We'll cover advanced arithmetic, so fractions, decimals, exponents, rounding, significant digits, scientific notation. Everything you need to know about how to manage numbers all the way through full-on algebra. All right, in the second semester, it'll be geometry, and we're going to cover Euclidean geometry, which is kind of the traditional 8th grade geometry, up through an introduction of trigonometry and analytic geometry, so things like the Cartesian coordinate system, using sine and cosine and tangent within that environment. And these things will become extremely important as we get into physics in future years. We'll talk about concepts like perimeter and area. We'll teach you how to compute those for certain specific things. Volume. We'll introduce the unit circle, which is boring, you think, but it's actually one of the most useful things that you can ever have, because we use that as a construct to really break down a lot of the really challenging problems into things that are something a computer can do. So ride with us. By the end of the year, we'll have completed all of geometry, we'll complete pre-algebra, and we'll roll straight into algebra next year. Okay, so Bug Hunter Challenge. I told you before, I make mistakes. I make a lot of them. My wife will testify to that. I guarantee you I've got errors in the presentation materials. I'll have errors in the text. The Bug Hunter Challenge is your opportunity to find as many of those as you can and prove that you're a better editor than I am. So if you find an error, it doesn't matter whether it's grammar or something technical, post it to the forum. I'll have a Bug Hunter Challenge thread in the forum. But you can't just find the error. You got to find the error and then tell me how to fix it. If you do those two things, I'll give you a point for each bug you find. I'll keep track of who finds the most bugs, and at the end of the year, every May, we'll announce the Bug Hunter Trophy for whoever collected the most bugs and call you the Grand High Bug Hunter. It's just bragging rights. Doesn't come with any money or any other prestige. But I look forward to seeing what you guys find. Alright, so the first assignment, you need to log in to the website and make sure that you have forum access. Once you have access to the forum, get onto the Foundation Math subforum. You'll need to request access to that forum. Post a 2-paragraph introduction about yourself. Now, in that introduction, don't tell me anything that you don't want the public to know. I don't want to know your age, birthday, your street address. Don't post anything on there that you don't want the world to see. The forums are limited to just the class, their parents, and our staff, but it's good practice to get into to really control your personal information. So even in a controlled environment like this, don't be putting things on the internet that you don't really want the rest of the world to see. While you're on the forum, find 2 other people that you can respond to with at least 1 complete grammatically correct sentence. Fair warning on the forums, I will correct grammar from time to time, especially if it's egregious. So use the best grammar you can. I'm not a grammar Nazi. I'm not going to correct everything. I'm not going to be real pedantic, but do your best, because writing is a skill that we think is super important, whether you're a technology guy or a liberal arts guy or gal. The next thing is read sections 1.1 and 1.3 in the book. This is on quantity, subitizing, and body counting, because that's what we're going to talk about in the next lecture. Alright, that's it for today. I apologize for the rather long and boring lecture. Hopefully the rest of them will be a little more interesting, a little shorter, and a little more application, but get all the dirty business out of the way, and we'll see you next time.